Okay, we're going to now talk about the abstract word problems from Lesson 9. And I'm going to just go through it. There is a typo. It should be that Linda drove m kilometers at p kilometers per hour, got to the market 2 hours late. They want to know how fast she should have gone to get there on time. Now remember, distance equals rate times time. So I'm just going to write the formula. We said she went m kilometers, so that's the distance. Her rate was p kilometers per hour, and we want to know the time. So what we have is we solve for time, and we get m divided by p is the time. But that was 2 hours late. So if we want to be on time, we have to subtract 2 hours. So the distance is still m. We want to now find the rate for her to be on time. So now distance over time. So now what we have here is p equals m over p minus 2, distance over time. The rest is just algebra, trying to simplify the complex fraction, getting a common denominator, stay, change, flip, and then multiplying it through. Abstract means you're not going to get a number for an answer. Now this example says that Jill could do 3 jobs in J hours and Sharon could do S jobs in 5 hours. They want us to find out how long. That's not length, that's time. Find the time to do W squared jobs if they work together. Now the big assumption here is that their rate will be the same regardless of whether they work separately or whether they work together. So again, rate times time equals jobs. The rate of Jill is what we're looking for. She took J hours to do 3 jobs. So we solve for the rate and we get 3 jobs per J hours. The rate of Sharon times 5 hours gave us S jobs. So the rate of Sharon is going to be S divided by 5 jobs per hour. Now they're going to work together. So the rate of Jill times the time plus the rate of Sharon times the time gives us W squared jobs. Now the time is the same for both because that's how long it takes for them to work together. So now what I did is I factored out the time, parenthesis, rate of Jill plus rate of Sharon equals W squared. All I did was factor out the t. Now when I solve for t, it's W squared divided by these rates. What are these rates? Well, we found out the rates up here. So I substitute in the rates. Now it's just a matter of getting a common denominator. Multiply top and bottom by 5, multiply top and bottom by j, which is what I have here. And then I have to simplify the complex fraction. It's stay, change, flip. Stay, change this to a multiply, and flip this. And this is the time it takes for those two to work together. Okay, in example 3, Ryan and Steven saw that the number of cookies varied directly. Very directly. What that means is the number of cookies varied directly as the amount of sugar. Number, amount. I don't know what the constant of proportionality is. That's what I have to find out. If there were 5 pounds of sugar and it made D cookies, D number of cookies, we can then find the constant. The constant is then D over 5, cookies per pound of sugar. How many cookies would be produced if 10 pounds of sugar were used? Since this is a constant, it's the same direct variation. We use N equals K times A. We're looking for the number of cookies. The K we just solved for, and this is the pounds of sugar. So what we then have, notice number of cookies per pound times the pounds of sugar. Notice the units cancel out, and so we get the number of cookies. 5 goes into 10 2 times, so it's 2 DE pounds. All right, in example 4, Ryan and Steven's little sister found that she could buy Y items for D plus $6. How many items could she buy for $42? So what we're looking at is trying to find how the units correlate first. So what we're going to do is we've got the number of items per dollar. We said she could find Y items for this many dollars. Now what we've got is, if I have Y items, D plus $6, and I multiply it by dollars, the dollars go away and I get how many items. So now all I've got is 42y over d plus 6 items. Always check your units, and that will help you solve these problems. Example 5 has to do with age. This year, Stephen is twice as old as Tom. In X years, Stephen will be 5/3 as old as Tom will be then. Find the present age of Stephen in terms of X. So what we do here is I'm actually looking at now. So Stephen is twice Tom's age. In X years, that means in additional years. So what I did was said, S plus X equals 5/3 T plus X. Stephen's age plus X. Tom's age plus X. It could be 10 years, 5 years, 3 years, and that's what the top part told us. Okay? So now I need to find their present ages. So now what I'm going to do is I'm going to solve for t. Once I solve for t, I can then substitute it. So I simplified here, distributed. I substitute for t. Okay? Now I need to get the x's together. So now I have s plus x, and I simplified this problem here. So 5s over 6 plus 5/3 x. I get the x's together, and I get the s's together. This one here, if I put this as thirds and I bring it over here, I'm going to get 2/3 x. So I put the x's together, I put the s's together, and then I multiplied everything by 6. That got rid of the fraction. So now I have s equals 4x. So that means Stephen's age right now is 4 times whatever x is. All right, the last one in lesson 9 says that Gary had G gallons of a 60% antifreeze solution. Ed added E gallons of a 30% antifreeze solution. Final solution is 40% antifreeze. Write the expression in terms of G that represents the number of gallons that Ed added. So in other words, we only want G in there, not E. So let's set up first our picture. We have G gallons of the 60%. We have E gallons of the 30%. We add them together to get the 40%. Now I can write my equations. 0.6 times G plus 0.3 times E, it's 0.30, equals 0.40 times G plus E. So now what I have here is I got rid of the decimal, multiplied everything by 100, and distributed this through. 60G plus 30E equals 40G plus 40E. I get the G's together, I get the E's together, and I want to solve for, so I've got 20G equals 10E, and I need to know, I need to solve for E, because I want to know how many G, we want it, up here it says, in terms of G. So we really want to know what E is. E is 2 times G gallons. And now we've solved the last part of these abstract problems.